Sanibonani. Ubuyile indoda kaMageba. Namhlanje sizokwenza i-Euclidean geometry. So today we'll be doing some Euclidean geometry from grade 11. So even grade 12, you need this. If no muntu omaziyo who is doing grade 12, um, now we are still going to do grade 12, you're gonna need this in grade 12. So please guys, listen carefully. It's a very important lesson, this one. So we'll be doing some Euclidean geometry today. The theorem that we're gonna talk about is theorem 1. Is theorem 1, guys. Statement here are very important if you go far with this. So statements are very it's gonna be a very important figure. It's gonna be very important. So the line drawn from the center is perpendicular to the chord. That's what the first theorem is saying. Ithini kahle kahle? Ichaza ukuthini this theorem? Mase sesiyihlaziya kahle. Bathi a line from a chord. A line from the center, sorry, a line from a center. So now a center is this line from the center is perpendicular. Now a line from the center. But it's perpendicular to what? To a chord. Why in a chord is this line from here to here. So a chord, a line, esuka from circumference going to another circumference, but doesn't pass the radius. If a line that passes a radius from another circumference to another circumference, then that one is no longer a chord, it's a diameter. I hope you see the difference between a chord and a diameter. A chord, it's just a line passes phakathi nendawo, not phakathi nendawo, anywhere kwi-circle yakho going to another circumference, that is a chord. But if iline yakho idlula la center, then that is what? A diameter. So bathi la line from the center is perpendicular to the chord. So a line from the center is perpendicular to the chord. That's what we are giving. They are telling us that basitshela ukuthi a line from the center is perpendicular to what? To a chord. So we're gonna have just gonna name here. This is just gonna be M1. Sorry about this. It's M, guys. This one. So it's gonna be M1 and M2. Okay, basitshelile lokho. This is what it's giving from us. So I'm just going to write the given is that M1 on the 2LM is perpendicular to bani to ABS. Just going to say OM, it's perpendicular to bani to AB. That's what it's giving. It's giving. So what is required to prove? See, prove in the match. Require to prove. Yini lesiprova? If sitshelo okunye meaning prove okunye. If sitshelo okunye meaning siprova okunye. What is required to prove here, guys? Required to prove is that AM, this side leli la, but AM mele simprove ukuthi ulingana nobani no-MB. That's what we are proving. We prove ukuthi AM lingana nobani no-MB. Ilokho esikuprovayo. And then let's prove then. But before we prove, you have to do construction. We're gonna join this. Joining AO. We're gonna also join OB. There are two constructions that we need to do when we are proving this. So bhala phansi here that we joined OA and ubani OB. Very important to ukusho ukuthi we are joining these two things. Before we continue, if you're going to prove this, you must know incongruence, because we are going to apply incongruency here. So guys, you must remember congruency. Congruency, three things. There are three things that you need to know or to find in the Blauma triangles out two that you prove with both of these triangles are congruent. They are not similar, but they are congruent. Congruency is basically they are equal, but not similar, because similar is too different than congruent. I hope you understand the part, because in grade 12, when you reach grade 12, or someone who's doing grade 12 right now, we has what similarities, then you're proving similarities there, but we'll reach there. That for now, we're going to prove proving congruency using a triangle zethu amabili. So triangle yokuqala, so it's in triangle AOM and the triangle bani OMB. Ilawo triangles esizokhuluma ngawo la. These are those two triangles that we'll talk about. Asebenzeni-ke manje. Let's prove into yokuqala. I hope you see ukuthi la constructing this radius here, and also this radius here. Iradi, ukuthi siyazi ukuthi i-radius i-line esuka ku-center iya ku-circumference, another line esuka ku-center ku-circumference, then it's a radius. So mayisemabili, when there are two, we call it radi. Ngesingisi-ke bathi ama-plural ama-radius radi. Sisho njalo isingisi bafowethu. So u-A, O uyalingana nobani no-OB. Why? Because amaradi. Two radius. There are two radius that are equal. We call them amaradi. Then let's move on. Number two. Number two, they told us ukuthi OM is perpendicular to bani to AB. OM, they told us ukuthi perpendicular to bani to AB. So lokho kuchaza ukuthini? Kuchaza ukuthi M1 uyalingana nobani no-M2, finda lingane nobani no-90 degrees. Perpendicular means something has to be 90 degrees. And being the reason it's given, guys. You're being told. There's no need of finding a reason or what. They told you these two things are perpendicular, meaning when they are perpendicular, they are forming an angle which is 90 degrees. Then we start to here. I hope you're gonna see this one. This this one. Lo OM ukhona kule triangle engapha, and also this OM we find it in this triangle on this side. So OM is equal to OM. Why? Because ukhona to this side of the triangle, and also ukhona to another side of the triangle. So these triangles are common. So now since it's only this is 3, We have three things now. Three things says now. So if it says there's 3, now we can say lama triangle two anjani congruent. So now we can say therefore triangle A O M congruent to the triangle O M B. I hope you see that one. Hope you see that one. Why, why, sisho njalo? We have a right angle. This R stands for right angle triangle. This H stands for usine right angle triangle, which this H stands for a hypotenuse side. If we're having a right angle, the right angle opposite to this side, which is our hypotenuse, this H stands for our hypotenuse side. And then we have this S, which is just a side, this one, which was our common side. I hope you remember congruence, guys, in grade 10. Therefore, if sesiphuvile i-congruency, therefore u-A M usiyalingana nobani no-M B. Now this sekuyalingana because we've already proved ukuthi i-congruence ukuthi lama triangle ethu wo-2 they are congruent or they are equal, but they are not similar. I hope you get that one. Now we are done with our first theory, guys. Make sure you know how to prove this theorem. Grade 11, grade 12, you need to know how to prove this theorem. They can ask you to prove this theorem, practice it, understand it. Make sure you do understand it because it can be asked in your exam or test or anything. You need to know this theorem. And then, guys, understand this theorem because we're going to go to another theorem, which is theorem 2 and theorem 3. Sorry, they come from this and this theorem. So if you don't understand this theorem, it's going to be difficult for you to understand the other theorems. So please understand it before you move on to another video or to another theorem. And then now we're going to do theorem 1. It's part of theorem 1, this one. We call it theorem 1. This was theorem 1A. This one is B. Why B? Because it's a theorem that is converse to in the first theorem. It's a converse of the first theorem, meaning it's an opposite of the first theorem. It's in this one. It's saying a line from a center. It's a midpoint to a chord. A line from the center. Now a line from the center is a line. It's a midpoint to a chord. Mabesho njalo kahle kahle bathini? Bathi le line le ihlukanisa lama line lawa equally because mawuthi midpoint the middle ephakathi nendawo. So le line le ihlukanisa u-AB kabili phakathi nendawo. Meaning what it's given here, we are given that u-AM uyalingana nobani no-MB. This is given. I've been told basitshelile ukuthi AM elingana nobani no-MB, meaning this is equal to this. Ne? Then what is being required us to prove then? Yini ke into esimele siyiprove? What we are going to prove here. So prove ukuthi. Just gonna call this 1 or 2. Let's see prove. You're proving that OM is perpendicular to bani to A bani B. Or si prove go to UM1 which is an angle iyalingana nobani no angle 2, which is ulingana nobani no 90 degrees. This is what we are required to prove. This is the required to prove. Into kumele siyiprove this one. So now let's prove. Remember, before we prove, we need to do our construction. Then let's construct here our radius. We're constructing our radius. Constructing our radius. So now we can say here we've joined A, O, and we have joined one O, B. That's what we have joined. Our radiuses, we call him radi, masimabili or more, amaradi. Then let's continue to prove. Remember, guys, to prove this theorem, you need to know congruence. Sengichazile i-congruence ukuthi yini izinto esiyidingayo if you are proving what the congruence. Angeke ngisagxila kakhulu lapho. Let's just move on. In triangle AOM and congruence esiyipruvayo ila kulama triangle lawa and triangle bani OMB. Are proving congruence between those two triangles. Let's start. Remember, guys, we just constructed these two. And these two. This is a six-shilo in the first theorem, in the first part of the theorem, which is called Theorem A1. Sathi O A uyalingana nobani no O B Y, because amaradi lawa, there are two radiuses that are equal, so we call them what? Amaradi. Call them what? Amaradi. Then we continue from number 2. Guys, there's a given. Don't forget the given part. That's the free mark. It's given. They told you. Basinikeze inike la. Basitshelile ukuthi u-AM uyalingana nobani? Uyalingana nobani? No-MB. Basitshelile. It's given. So you can write it if it's given. Because they told us there is no need to think of a reason, but it's given. But you must know the reason, guys. Make sure you do know the reasons. Then number 3, another one. I hope you still remember this one from the first part of our theorem. Is here, which is one OM. The OM. OM ukhona to the first part of a triangle yethu, and OM also siyamthola to another second part of a triangle yethu. So OM. OM is just a common side. So OM uyalingana nobani no OM, which is just common. OM is just the what? The common side. Hope you still remember that one. Hope you do. Hope you do. And then, mase sesinjalo, sesiqedile. Sesitholile izinto ezizothatha esiy'dingayo if you're proving what? Congruence, because we need just 3 things. Bararo. We just need 3 things. So we can say now, therefore, in triangle AOM, it's congruent to triangle bani OMB. Why? Because namaside sinamaside amathathu anjani alinganayo. Hope you see it. Hope you see. I hope you see, guys. I hope you see. I hope you understand it. Now, masinalis into zo 3 efanayo, we have proven our congruence. Now we can conclude. Since therefore, M1 uyalingana nobani no M2. Ne? M1 uyalingana no M2. But buka-ke guys, but ubani u-A M B, it's what? It's a straight line, this one. U-A M B, it's what? It's a straight line. It's a straight line. So if M1 and M2, my angles are a straight line, but at the same time, M1 and M2 bayalingana. Remember, these things masihlanganisa, they have to give us 180. Angle at the straight line around 2, 180. So in my plan, my angles out 2. Eso maswa eda. Azoskipel 180, but mela fang. Ubani? Just to be 90. Away come on. So to M1, uyalingana nobani no M2, which alingana nobani no 90 degrees. Why? Because angles at a straight line add up to 180 degrees. Sesigqibile bafowethu, siqedile, sesiwaphrovile ama-theorem ethu amabili. Thank you so much, guys. I hope you did enjoy. Hope you did enjoy this video. As I did, I really enjoyed it. I hope you guys, please make sure you understand this theorem. I'm just gonna do the second part of it where we are proving. We are doing examples of these theorems. I hope you did enjoy it. Make sure you catch the second part of it where since I'm an example. Thank you so much, guys. If you figure out in the video, I really appreciate it. Like, share the video, subscribe into the channel. It's really gonna grow us, guys. It's a cool song, and so that other people who are coming the following years who are still coming, guys, they're gonna see this video. Share it. It's very important. Thank you so much, guys. I love you so much. Wow, Tanda in the market. Thank you. Cheers, man.